Hello students, today we are going to see longest common subsequence using dynamic programming. What do we mean by longest common subsequence? Longest common subsequence is a common problem in computer science and dynamic programming which involves finding the longest sequence of characters that two sequences will have in common. Okay, means we will be having two strings or maybe two different set of characters, and we are supposed to find the longest sequence of characters which both of them will have in a common. Okay, but there is no need to have those characters at the same position. Okay, first we'll discuss the examples. Now see here students, we have two different strings A, B, C, D, E, F, G, H, I and J. The first string contains these characters and string 2 is having four characters, that is C, D, G and I. Now these two strings are not substring of each other. Okay, they are not substring, they are two different strings. Okay, now here we can see that there are some set of character in string 2. Okay, which are appearing in string 1 also. For example, you can see here the alphabet C. Okay, C is present in string 1 also and in string 2 also. Similarly, in character D, which is present in string 2 also but string 1 also. G is present in both the strings and I is also present in both the strings. Now we have to find which set of characters is coming in sequence. Okay, means in common. Now see here students, I have used the blue color arrow pointers here. See here, C is matching, fine. D is also matching, G is matching and I is matching. Here we can see that all the characters are present in string 1 in same sequence. See here, means there is no situation where D is appearing before C here and here it is appearing after C. No, as C is appearing first in both the strings. Similarly, D is appearing in both the strings after C. Similarly, G also. Though there is a E and F in between D and G, but yes, it is not coming before D or before C. So it is considerable. In this way, we can see that CDGI is the longest common subsequence. Okay. Here we can see that all the characters are present in string 1 in the same sequence, although they are not together. Okay, so CDGI is the longest common subsequence. Now I'll show you one example where the case is different. See in this example, in the previous example only, I have added E here. E, C, D, G, I. This is our string 2 and string 1 is same as that of the previous one. Now let's start with E. Okay, E is present here. Yes, so I have draw a blue color line. Now see here, next alphabet is C and D. Now C and D are appearing before E in string 1, but in string 2 they are appearing after E. So this is not a subsequence because C should be following the E and should not be at the back of the C. Similarly for D also, D should appear here after E and not before E. So we can say that this is not a longest common subsequence, but yes, there can be a different set of characters which may be a part of longest common subsequence. So here we can see we have discarded C and D here as they are coming before E in the string 1 and after E in the string 2. Okay, so let's see if there are any other characters. C, D are being discarded. Now next is G. Yes, so G is present after E in the string 2 and in string 1 also. Similarly, I. So here EGI can be a longest common subsequence. See this example. E, G and I means how you can identify. Suppose if I draw a line here, the line, if two lines intersect each other, that characters cannot be counted as a longest common subsequence. Okay, so in this way you can identify which character set can be a part of longest common subsequence. So here you can see E, G and I, they have not intersected each other, where C and D have intersected with E. So here EGI is the longest common subsequence. Next. So above example summary is, we have understood that the set of characters should be matching. Okay, although the matching characters need not be continuous, maybe some other alphabets are coming in between these two, still we can call them longest common subsequence as the set of character is present in both the string. Okay, now let's see how to solve these problems with the help of dynamic programming. Till now we have seen the example in a string matching. Now we will do the longest common subsequence solved with the help of dynamic programming. Now see this example, students. Here we have string 1, B and D. This string 1 contains two characters, that is B and D. And string 2 we have as A, B, C, D. Now the rule for dynamic programming is it follows the bottom up approach. Now you will understand when I solve this example what do we mean by bottom up approach. Now what the algorithm says, that if there is a match, then add 1 to the previous diagonal element, else take whichever is the max of the previous row or previous column. Means what, students? Here we are going to construct a table. In a table, see here, I'll show you. Now see here, I have taken string 1 in a column and string 2 in a row. Here column representing the string 2 and row representing the string 1. And here we have stored the index 0 here. Now we want to start this algorithm, and to help this algorithm to proceed, we need to fill first row and first column with 0. Here we have used index 0 because we want to fill the initial values with 0. Why we have filled this 0? To start with the algorithm. Okay, this help our algorithm to start. Okay, now next slide. Now as per our rule, what we are going to do is, see if this character means first character of row 1, if it is matching with first character of row 2, wherever they are intersecting, we are putting what, as per algorithm, the diagonal value plus 1. Okay, means suppose this B, if it is matching with A, then we will write here what, 0 plus 1, which is 1. But is it not matching, so we will straight away put 0 here. Okay, not 0 necessarily, we will put what, whichever is maximum, means this column, the previous column or previous row, whichever is the bigger element out of these two, we will add over there. Okay, so let's see how we have solved this example here. Now see students, we are going to match this alphabet B from string 1 to the first alphabet of string 2. Okay, so here the first alphabet of string 1 is B and second alphabet is A. So is B matching with A? No. So in such case, what we have to do, previous row and previous column, whichever is bigger, that we are going to add here. But as it is 0 in previous column also and in previous row also, so we are straight away going to put 0 here. The reason is both are 0. Okay, let's move on. Now this B is matching with B here. Okay, so B and B both are matching. So the rule is, when both B and B are matching with each other, what we are going to do is diagonal element plus 1. So for this cell, the diagonal element is 0. So 0 plus 1 is 1. So yes, here we have added 1. Next is C. Is it matching with B, students? No. But when it is not matching, what is our rule? In column, previous column or in previous row, whichever is the bigger one. Now whichever is bigger here, 1 is bigger. So in this cell, the previous column's big element 1 will appear here, as this row contains 0 and between 0 and 1, 1 is maximum. Hence we have written 1 here. Now next we are matching B with D. Is it matching, students? No. So we will check the previous row and previous column. So as you can see, the previous column contains 1, which is the bigger one. So we have added 1 here. Now let's move on to the next character. Now we will match this D with A. Is it matching, students? No. So we will check the previous row and previous column. Both contains 0. Hence we will put up 0 over here. Now let's match D with B. Is it matching? No. So we will check previous row and previous column. So for this, previous row is this one and previous column is this one. So column contains 0 but row contains 1. The previous row which contains 1. So 1 is bigger than 0. Hence we have put up 1 here. Now next is D we are matching with C. Again D and C are not a match. So what we will do is we will check previous column and previous row. Now here previous column is also containing 1 and previous row is also containing 1. So straight away we will add 1 here. Now let's see the last element D. Is it matching with this D? Yes. So what is the rule? If the match is found, you will add +1 to the diagonal element. So for this cell, diagonal element is this one. So this one plus 1 becomes 2. Hence here we have written 2 students. Now next slide. Now you can see last element represents the longest common subsequence. Means what? In our example, we have found the longest common subsequence of set of 2 characters. Okay, how we have come to know that? We have got set of 2 characters because of this last. As it is a bottom up approach, here you can see the last element is defining the longest common subsequence. Means here our longest common subsequence has 2 characters. Okay, but which those characters are? Means out of ABCD, which common subsequence we have found? So let's check that, students. Now here, whichever element we have found by diagonally adding 1, that is the part of our string. Okay, so here you can see the diagonal arrow means these two we have got from by adding 1 to this element. Means 1 plus 1 is 2. So this is diagonally added. So D is part of our longest common subsequence. Okay. Now how we have got this one? We have got this one from here. See, as C and B are not matching, so we have simply taken the big element of this previous column 1 here. Means how we got it? Yes, by simply taking the maximum of previous row or previous column, whichever is max. Okay. So means this is not diagonal one. This arrow is not diagonal. Okay, so this is means C is not part of our longest common subsequence. So till now we have got first character D. Now which one is the second character? Now how we have got this one? By diagonally adding 1 to this 0. Okay, means the B we have got by diagonally adding 1 to this 0. So our second character of the longest common subsequence is B. So you can see here D and this B and D are the part of longest common subsequence character set. A place from where we have gone the diagonal is the sequence that we are searching for. Okay, so I hope you have understood this example. We will do one more example for better understanding of this algorithm. Okay, here the string 1 is BDCB, which I have put up in a column BDCB, and second string is BACDB, so which I have put up in a row. Okay, now here again the last element representing the longest common subsequence. Now I'll show you how I have filled this table. Okay, the green mark zeros indicating what? The initial value that we have started our algorithm with, that is 0. Now this 0 is going to fill us the entire table to get our result. Okay, now see here, students. First we'll start with this B. Is this B matching with the B? Yes. So the rule is when the character is matching, we will add +1 to the existing diagonal element. So here diagonally it is 0. So 0 plus 1 is equal to 1. Okay. Now let's match this B with A. Is it matching? No, students. But when it is not matching, our rule is what? What we have to do is we have to check the previous row or previous column to fill the cell, whichever is the maximum. So in previous row it is 0 and previous column contains 1, and out of 0 and 1, 1 is the maximum. So we will write 1 here. So even though B and A are not matching, but its previous column contains the big element 1, so we will write here. Now B is matching with C. Is it so? No. So what we will do? Previous row and previous column. So previous column contains 1, previous row contains 0. Out of these two, 1 is bigger than 0. So we will add 1 here. Now let's match B with D. Is it matching? No. So what we will do is we will write previous column and previous row, whichever is maximum. So I can find that the previous column contains big element than the 0. So I have simply write it over here. Now next is B. Is this B matching with B? Yes. So in such situation we add 1 to the diagonally present element. So diagonally it is present 0. So 0 plus 1 is equal to 1. So 1 has come over here. Now next match this D. Is D matching with B? No. So we will check the previous row and previous column. So here previous row contains the big element. So here I have written 1. Similarly D and A, if you match, here both are not matching. So I will go for previous column and previous row, and whichever is the big element I will add over here. Now here row and column both are contain 1. So you can write 1 here. Okay. Similarly, is D matching with C? No. So again, previous row, previous column. The 1 is present at both the places. So you can write 1 here. Now next is D. Is it matching with D? Yes. So what we do? We write in this cell whichever is the diagonal element plus 1. So diagonal element is 1. So 1 plus 1 is 2. Okay. So I have written 2 here. Now D. Is it matching with B? No. So we will check previous column and previous row, and whichever is big that will be right here. Now see, previous column contains 2. Previous row contains 1. Out of these two, 2 is bigger. So I have written 2 over here. Now let's proceed for C in a same fashion. Now as you can see students, here C is written and here B is written. Are they both matching? No. So what we will check? Previous row and previous column. So you can see 1 is the big element than 0. So we have written 1 here. C matching with A? No students. So again we will check row and column. Now both of them contain element 1. So yes, we have written 1 over here. Now let's match C with C. Is it matching? Yes. So when it's a match, our algorithm says add 1 to the diagonal element. So diagonally here it is 1. So this 1 plus 1 becomes 2. Now let's check C with D. Again it is not matching, but previous column and previous row if you see, both of them contain 2. So you have to write here 2. Now is it matching C with B? Again no. So we will check previous column and previous row, and both of them contain 2. So we will write 2 here. Now let's check. B and B is a match. So diagonal element plus 1 is 1. Okay. Now let's move ahead with A. Is this A matching with B? No. So we'll check previous row and previous column. So here 1 is bigger. So we have written 1 over here. Okay. Now B with C. Is it matching? No. So previous column and previous row, whichever is bigger, we will write here. So here we have written 1. Now let's check students. B. Is it matching with D? No. So previous column and previous row, whichever is bigger. So here 2 is big. We have written 2 over here. Now B. Is it matching with this B? Yes. So in such case, what we do is diagonal element plus 1. So here 3. Means again the last element represents the longest common subsequence. Here our longest common subsequence has 3 characters. But which these 3 characters are? Now let's find out. Now, as I said, the diagonal element, the element that we have got by adding 1 to the diagonal element will be a part of our longest common subsequence. Okay. I repeat, the element that we have got by adding 1 to the diagonal element will be the part of our longest common subsequence. So here you can see B 3. Now 3 we have got by adding 1 to these two diagonally. So yes, so B is part of our longest common subsequence. So I have put up it here. Now next, how we have got these two? We have not got these two by adding diagonally 1, because we have got from here the biggest row and biggest column, whichever is the maximum. So we have got these two from here. So again we'll check how these two have come. These two we have received by adding 1 to this element diagonally. So C has received by adding 1 to this diagonally present element. Hence I have put up C. Means C is the second character from our longest common subsequence. Now next, how we have got this one? By adding 1 to this diagonally present 0. So 0 plus 1 is 1, means this B also a part of longest common subsequence. So students, for our previous example, BCB is the longest common subsequence that we have got here. Okay. Okay, now we'll start with the algorithm. Whatever example we have solved today are with the help of the rule explained in this algorithm. Now what this algorithm says, you have to compare the two characters from set given to you, both the strings. Then if the characters is a match, means that both characters are matching with each other, then you have to add 1 to the diagonally present element. If it is not a match, then you have to choose the max between row and column, whichever is the maximum, that will be your next filling of your table. And this is how we are going to find the longest common subsequence. I hope you have understood this video. Thank you for watching.